Good morning students, 12th standard physics, so lesson 3 magnetism. So in this class we are going to discuss about motion of a charged particle under crossed electric field and magnetic field. So it is also called velocity selector. So consider a positive charge. So consider a positive charge moving with velocity v. So it enters into the uniform magnetic field as well as uniform electric field. So electric field and magnetic field are perpendicular to each other. So due to that, so there is a change. If it is a positive charge, if it is enters into the electric field. So electric field means, consider here there is a parallel plate. So that is capacitor here. So capacitor means, so one plate is positive charge, another plate is negative charge. So electric field starts from positive to negative. So if it is a positive charge enters into the field, so due to positive charge, so it's deflected towards the negative charge. So there is a deflection towards the negative charge. So there is a uniform magnetic field is there. So there is a deflection in opposite direction. So it's a crossed electric field and a magnetic field. So consider here this one positive plate and negative plate. So it's a positive charge moving with velocity v. So it is positive, it is deflected towards negative. Then the north pole and south pole provides a uniform magnetic field. So magnetic field starts from north and ends south. So already we know. So there is a deflection is balanced by the magnetic field. So if it is charged particle moving in a magnetic field, means there is a Lorentz force acts, there is a centripetal force, a force acts towards the center, but if you apply a proper electric field, that is balanced. So the electric field and magnetic field is balanced, the deflection of the positive charge. So it's a crossed magnetic field and electric field means, so consider this one. So this one, so positive charge and negative charge. So the plate, that is positive charge, the single charge moves. Now the crossed magnetic fields, here two plates in this side, the north pole and south pole. So the deflection towards the negative is balanced by the north pole. So the north pole consider as it's positive. So it's what will do? It reflects. Then south pole it attracts. So consider north pole and south pole as plus and minus. So if you can understand more easily. So if it is plus means, if it is minus, so it's towards negative deflected. So due to the positive, that is north pole, it deflects back. So it means it repels back. So the negative charge it attracts. So there is no deflection. So the deflection towards negative is balanced by the magnetic field. So it's vice versa. So this is a concept behind the question. So Lorentz force is balanced by the Coulomb force. So Lorentz force is magnetic force, Coulomb force is electric force. So what's my crossed fields? So it's an arrangement. Both electric field and magnetic field are perpendicular to each other. Then the parallel plate capacitor provides the electric field. Then uniform magnetic field is produced using a bar magnet or electromagnet. Then what is the net force acting on a particle if it is entered into the cross magnetic field and electric field? So the net force F is equal to Q times, so electric field, it's a sum of electric field plus V cross V. So already we know the positive charge, if it is entered into the electric field, so it deflected towards negative plates. So it deflected downwards, but the magnetic force balances and make it upwards. So it's downwards and upwards. So the electric field, that is electric force and magnetic force, is balanced due to the cross electric field and magnetic field. So balance one another. So electric field E is equal to F by Q. So F is equal to EQ. So that's all. So we have studied in first lesson. So the electric force is EQ or QE, both are same. Then magnetic force. So F is equal to BQV sin theta. If it's an angle between B and V is 90 degrees, so F is equal to BQV. So it's BQV, that's all. So V is the velocity of the particle. The force F is the magnetic force of a particle moving with velocity in the electric field, in the magnetic field. So the magnetic force is produced due to the magnetic field. Here electric force due to that electric field. So F is equal to EQ. So both, this is first lesson, this is third lesson. So F is equal to BQV. Then one is balanced by another. So just you need to equate. So QE is equal to QV0B. So V is a velocity. So QQ cancel. So just you rearrange. So velocity v is equal to the electric field by magnetic field. So already we know the values of electric field and magnetic field. What is the velocity of the charged particle? So from this we can fix that velocity. So that independent of mass and charge. So the velocity of the particle is, it is independent of mass. So just the final velocity v is equal to E by P. So in this, from this we have infer from that is independent of mass of the particle and charge of the particle. Then three special cases are discussed. If the velocity v, so velocity v is a charged particle, that is charged particle's velocity before entering into the chamber. V0 is a magnitude of E by B, that is where v is equal to E by B, then we will get some value. If the velocity v is greater than V0, deflects by the charged particle, deflects by, that is Lorentz force, that is magnetic force. If it is v is less than V0, again there is a deflection due to Coulombic force, that is electric force. If electric field, if it is v is equal to V0, the charged particle's velocity and electric field magnetic field value will get some value. If it is both are same, means there is no deflection, so it moves in a straight line. So because the negative charge, if it is in the negative plate, is downwards, then the magnetic field make it upwards. So again there is no deflection, it goes in a straight line with proper velocity. So velocity selector is nothing but by proper selection of electric field and magnetic field, the particle move with particular speed. So it's also called velocity selector. So this is a working principle of Bainbridge mass spectrometer. So it is used to separate the isotopes. So isotope means, so hydrogen 1,1, hydrogen 1,2, hydrogen 1,3. So what is, this is the isotope of hydrogen. So same atomic number but different mass number. It's hydrogen, deuterium and deuterium. So we can separate using the Bainbridge mass spectrometer. So it is the working principle of that Bainbridge mass spectrometer. So it's velocity selector. So if a charged particle moving in a crossed electric field and magnetic field, so the velocity is properly fixed by the values of electric field and magnetic field. So some concept is behind the question. So okay students,